Hi, great. Hi, I'm Rohit. I'm the consulting director for Frost and Sullivan. And today, I think it's very fortunate that I may be able to engage industry experts as yourself on a very crucial topic, which is autonomy in aviation. So, broadly talking, I would like to discuss today, if you're fine with it, about autonomy in terms of both in drones, in terms of how it is going to affect the unmanned aerial mobility, how it is going to affect the smaller aircraft, how do we see autonomy progressing, and what are the requirements for that. So this is in a nutshell the focus of this particular talk today. And let me invite first you to introduce yourselves, and then we can perhaps take on the topic.
Yeah, no, good afternoon. So I'm Pierre Byte. I'm the president and CEO of Aurora Flight Sciences, and joining me today is.
I'm Mike Kimona. I'm our Chief Customer Officer for Aurora Flight Sciences.
Great, great. Thanks for the introduction. So maybe we can just start with Mike understanding a little bit about, the technology roadmap. How do you see the technology progressing so that we start moving towards more autonomous vehicles in the aviation part or in the aerospace part?
Yeah, absolutely. I think as an industry, there's just a ton of work happening across the spectrum of autonomy. And we're really focused on everything from foundational research that has to happen from algorithm development and perception systems through applying that autonomy into different use cases so you can start to do some incremental testing in the airspace all the way through delivering final products. And so it's a very collaborative industry from sensor providers and technology providers, platform providers, but we really have to think as an industry about that entire ecosystem from the foundational research, through the applied autonomy into the kind of final products. And so that the product roadmaps are really kind of following that, that method. And then also I would say that, you have the full spectrum of small drones into larger passenger vehicles, and also, moving cargo and understanding that before you really get into moving people.
Yeah.
So I think the roadmap kind of follows that trend.
Yeah, a couple things I would add to that is a lot of people, when you think about autonomy and think about autonomous flight, we start to think about the platform, but it's really the entire ecosystem. It's the things that are on the ground, not just things that are in the airplane. And some regards, I think of autonomy can be a really easy problem to solve. So if you're flying from, let's say, Dubai to Abu Dhabi, and it's a beautiful day, the ground crew is rested, everything works, it's not that difficult to do. But the hard part, and as a pilot, is that when things go wrong. And so you have to develop an autonomy system that allows you to operate when things don't go right, when GPS doesn't work or some other device, some redundant system fails. What do you do when things don't go perfect? And so that's the key to autonomy, is really understanding how to think like a human would as an operator. If you're a pilot, the things that you just naturally learn as part of your training, how do you get the machine to do that for you? So that's one of the challenges, and that's why the roadmap and the technology roadmap is so important.
Absolutely, and yeah, I hear you. I've been in some crazy situations where autonomy was absolutely something which saved the day for us, and yeah, I agree with that. So, on a top level, what do you think are the drivers for it? Why autonomy? How is it going to affect the end customer? How is it going to affect his not only performance but perhaps also his financial considerations in terms of how does it help him make a better business out of it? What are the drivers for that?
Yeah, I think there's a couple drivers. The number one driver, quite frankly, is safety. Like, how do you get more safety into aviation? And we think that putting more autonomy, whether it's assisting the pilot or full autonomy without a pilot, you can do that in a much more safe manner. And so how do we get to a really safe autonomous aircraft, a safe autonomous operation? Again, is rolling through these different technologies that allow us to get there, like the redundancy. Like modeling and simulation is another key aspect of proving, how you get there. So, Mike, other thoughts?
Yeah, I think that also, you have to think about autonomy as there's a sustainability aspect to it as well, right? So there's a driver of pilot shortages, being able to use autonomy for reduced crew operations, optimizing your flight performance for fuel efficiency, and then obviously, safety is still the number one. The use case is really safety is driving the use of autonomy, and it's also to some extent metering the progression of of autonomy, because we won't implement autonomous vehicles until it's safe to do so,
Yeah,
right?
yeah.
And so this safety is really a driving force behind it, but like I said, it's also metering the pace
Yeah.
in a logical way.
Yeah, the other thing I would add is we're at an air show, right? And it's about how do you increase, traffic in aviation. And so the economics of it is there aren't enough pilots. And if you look at the growth of aviation, whether it's, small passenger type aircraft and electrified aircraft or large aircraft, there aren't enough pilots. And so putting autonomy to aid the operators are something that can make it really economically beneficial for you.
Yeah, absolutely. Safety is, of course, the most critical part. And as you said, it's both a driver and perhaps it's also metering the progress. What are the other restraints which you see to moving towards an optionally piloted aircraft or towards a fully autonomous aircraft? Perhaps two come to mind: regulations. One, the other part is the public acceptance. How do you see these 2 points evolving in terms of both regulatory requirements and clearances as well as the public acceptance of the same?
Well, we think of it this way, we talked about the technology roadmap to get there, and that'll take some time to prove out the safety. But the regulatory is really important, that we work with the regulators, FAA in the US, EASA in Europe and so forth. And it's such, it's an ecosystem of how do you get there as an industry, not just how do we get there as a company. And that's why it's important that all industry work together with the regulators and figure out how do you implement, how do you define the regulations for safe autonomous flight. And so that's why going through their incremental steps, it's easy to start with the drones today. They're pretty ubiquitous, but drones tend not to operate in the national airspace, with the rest of the aircraft. And so how do you start to build up, again, that trust, the reliability, and the ability to collaboratively work together?
And if you think about that as it relates to having an optionally piloted aircraft, right, as the customers are kind of growing accustomed to the regulatory environment, having an optionally piloted platform does exactly that. It gives them the option to adjust their performance, adjust their operational requirements as the regulatory environment is taking shape, right? So, you can have an airplane that can be piloted, and then in certain use cases, in certain safety cases, you can implement that autonomous position, right? And so that gives you that kind of flexibility as a customer. And so that's a key thing for us, to be able to have that spectrum of autonomy from piloted to optionally piloted with perhaps a safety pilot on board through full autonomy. And there are just so many different safety use cases that I think that gives us that flexibility.
So, I'd like to follow up that. Thanks a lot for that. And I'd like to follow up with a question on that where are we on there, both as an industry, within this roadmap which we're looking at, as an industry, where are we? And maybe more specifically, maybe you could, let me know about where is Aurora Flight Sciences in terms of the adoption of this or the go-to-market kind of a time frame which it is looking at.
I think overall, as an industry, we're all progressing, I'll say together. And as I mentioned, there's a lot of autonomous aircraft in the market today, but again, not the version that are actually carrying people. So when you think of that progression of the roadmap and starting with simple things like could be just sensors, moving to cargo and eventually moving to people, and again, building on that whole theme around safety and getting to safe flight is a key aspect of that. So from a timing standpoint, sometimes we could ask the question is, hey, when are we going to get full autonomous flight? And the answer is when it's safe to do so. And so that whole drumbeat around safety is the most important thing, and that ties in with the regulatory side. And if you think about carrying people, you also have the social side. Are people going to want to sit in on an airplane that has no pilot? Do they trust the system to do that? I talked to my wife; she never will. My son, when do I sign up?
Yeah. Mike?
And I think as it relates to the specific work that Aurora is doing in this environment, so we do have a really significant small UAS program, and that's allowing us to really test the fundamental perception management, the autonomy, the autonomous behaviors, being able to use a simulation environment. We have a lab environment where we can do different algorithm testing between manned and unmanned teaming, right? And then we have a model of a platform here called Centaur that is that optionally piloted aircraft that allows us to use that primarily in defense applications because it's a more manageable airspace, right?
Yeah.
The customer owns the airspace in that environment. And then lastly, in the more commercial space, and Pierre, maybe you can talk a little more about it, but we have a partnership with the company Wisk where we're developing that fully autonomous passenger vehicle of the future. And so we can tie those together so we can perfect the autonomy, we can perfect the technology, we can apply it in a defense use case, and then we can take those learnings and really start to shape the market from that future mobility market.
Yeah, and Wisk is a really good example of a company that Boeing is contributing to, and it is a fully autonomous aircraft that's a passenger vehicle, all electric, right? So from the sustainability standpoint, that's definitely the way that you want to go. It's not something that's going to carry you across the country, but certainly for urban mobility, it's a great way to travel, to avoid the traffic down below. But again, implementing those technologies that we at Aurora have been working on really for decades and implementing on some larger aircraft that's optionally piloted and also on drones as well, and then throwing a lot of the modeling and simulation on top of that. One of the other really interesting things about being here at the air show is there's a lot of startup companies, and Boeing also has kind of a venture capital arm that's supporting some of these companies. And so where do we find these niche technologies, again, driving that technology roadmap that we can implement and really take large scale capability and niche technology and bring those together?
Yeah, absolutely. So let me ask you, I understand that the timeline is as per the safety part, but which platform do you see it going first? Will that be a defense platform, or will that be an urban aerial mobility kind of a platform? What platform do you see it first being adopted in?
I think it's, quite frankly, it's a little bit of a race, that there will be commercial platforms that have great military application.
Yeah.
And there are certainly military applications, again, like Mike said, that control the airspace, and so their ability to operate under different rules, make it a little bit easier. So I think the industry and us as Aurora, and Boeing for that matter, we're not saying one is going to be before the other. We're going to evolve the technology collaboratively and sort of see who gets there first. But there's plenty of market and plenty of opportunity to address both sides of it.
And if you think of it from our perspective, in both of those use cases, there's some fundamental things that we have to make sure that we can perfect, right? We have to avoid other aircraft. We have to be able to detect and avoid other objects, cranes, trees, other things like that, right? Power lines. And we have to be able to land safely. And this all has to be done autonomously. So, that core conflict detection and resolution research and application is fundamental to either of those use cases, right? And so that's really where the majority of our focus is, right? And so the platforms and applying that technology to the platforms, it's going to come naturally, right? It's going to come in with every one of those use cases that we have to apply it to. But we really have to focus on, like I said, from that foundational research into applying it into small payloads that, that can fit the use case and can close the business case. And then, it has to have that, that ability to turn out a product at the end of the day.
Yeah, thanks. That's a very interesting perspective. And yes, maybe I agree. Maybe my question was not the best one in asking which product it will be deployed in. But perhaps then from a regulatory aspect or from a public perception kind of an aspect, maybe that will be easier to, comment on that. It might be that you see the defense platforms coming first. Would that be a correct assumption?
I think it's a reasonable assumption. I think if you look at so many technologies that we use every day today, was developed out of the government or the military side that has, go from militarized to commercialized. And we also think that some of the smaller platforms, like the passenger air vehicle size platforms of electrification, might be commercialized to militarize.
Yeah.
And I think there are also a lot of public-private partnerships, some formal and some informal, where the defense industry and the commercial industry are working together to try to solve some of those problems, right? Yeah. So not from a business solution, but from a technology perspective, right?
Yeah, great. So any last comments on this, Pierre, anything which you think that either the industry should do or either what Aurora is going to do? Or what do you really think? Any last thoughts on this?
I think we really have to think of it as a cooperation across the industry. I mean, there's literally hundreds of millions, if not billions of dollars that are going into this kind of industry of developing platforms and where you can put autonomy on these kinds of platforms. And so as an industry, we have to work together. If any of us has a bad day in industry, it affects all of us.
Yeah.
And so it's really important to have that cooperation. And so at the same time, we're in business and we want to get to market, but as I said before, we want to get safe to market, not necessarily first to market. And I think that's key in working with our industry partners, working with the technology companies, working with the regulators, and eventually working with the general population in easing their concern around how do I make sure that I get into this trusted, safe airplane that we all got to Dubai in a certain way if you don't live here. And I got on that airplane, I trusted I was going to get here safely, and I have and always have. And we need to get that same level of mindset, right, to the users. And that's true whether it's commercial users, the public, or as military users. Everybody wants a safe solution. It has to be that way first.
I really like that part, your safe to market kind of a thing. I think that's really code-worthy. That's a really good thought. Anything from you, Mike?
I think the other thing to consider is with so many different partners and there's so many different members of the industry, interoperability is going to be a really key factor, right? Because any given customer, whether they're a defense customer or a commercial customer, is probably not going to have only one solution. You're going to have multiple solutions, multiple platforms, multiple energy systems, and a pretty broad infrastructure, and you have to have interoperability between the autonomy on the platform, the autonomy that's dispatching different platforms, the ability to manage the airspace, and that all has to be done in some interoperable way. And I think that as an industry, we have to really think through that to make sure that we're not locking our customers into decisions where they can't then implement different technology. So interoperability is going to be key. Figuring out what those standards are, so that we can all develop to a certain set of standards, I think is going to be important.
Absolutely.
And there's some really good examples of that too. If
Yeah.
you look at like the auto industry, right?
Yeah.
Where 10 years ago it would be pretty hard, at least in the U.S., to drive from California to New York in an all-electric car.
Yeah.
Today, it's ubiquitous where you can find a charging station. And so if you think about that, apply that technology to the aviation business, it's that infrastructure, and that has to be a cooperation. It's not going to be a monopoly by any one company. And I think similarly, when you think about autonomy and the roadmap to autonomy, it isn't necessarily going to be a monopoly by one company. Again, that whole theme around working together to create that safe solution will benefit us all. And there will be many, many solutions, right? There's many car makers. We'll see many aircraft makers, especially in the smaller size aircraft.
Absolutely.
And perhaps one last thing to think about is that, the future environment is not going to be mutually exclusive where there are piloted assets and then there are unpiloted assets, right? So it's going to be manned and unmanned assets working together, right? Whether it's in a defense setting, right, which makes perfect sense, or you're going to have commercial aircraft that are operating with unmanned aircraft. And so you have to have that manned and unmanned teaming, right? That type of technology development such that it's not just unmanned vehicles coordinating with one another, but that relationship, right? And so that has to really develop. And so we put a lot of our technology power and a lot of our resources to try to solve that problem as well.
Yeah. So, I mean, would you say that it's a fair summary if I say that we are looking at, the convergence of the ecosystem, the technologies, as well as the industry on one hand, and on the second hand, we are just looking at that we should be safe enough to reach the market. Would you support me in saying that these are the two things which we actually, as the looking at when we talk about autonomous in aerospace?
Yeah, I think that's very reasonable, and kind of going back to your question around commercial and military, and sort of who has the right of way and how you use the systems for sure.
Yeah. Okay. Mike?
I think from a technology perspective, that future of flight is happening right now.
Yeah.
So the technology is here, And so it really comes down to making sure that it's safe to operate and that you've addressed those fringe cases, right? Because they will happen, and we have to make sure that we understand how to address that. And so that's kind of where we are. We have to make sure that that safety case is solid, but it's happening, and it's happening right now.
Great. Thanks a lot for your time, and it was wonderful talking to you. And yeah, thanks again.
Great,
Yeah.
thanks for the opportunity.
Thank you so much.
Yeah.
Thanks.